Welcome to Free Flow, the Health Tech Law and Policy podcast, where we explore developments in health policy and help you navigate legal and compliance issues that affect your business. I'm your host, Dan Orenstein. On today's episode, I'm joined by Eric Just, a healthcare data strategist with decades of experience across engineering, product leadership, and executive roles. Eric worked at Northwestern's Feinberg School of Medicine, where he built a pioneering financial, clinical, and research data warehouse. At Health Catalyst, he shaped the design of its analytic products and supported go-to-market efforts during a period of rapid growth. Eric has returned to hands-on operational work through consulting to stay grounded in real-world data problems and shape how AI fits into healthcare data strategy and execution. Hey, Eric, how are you? Welcome to Free Flow.
I'm doing well, Dan. Great to be here.
Great to have you. And I understand that it's the 5th anniversary of Just Health Technology, so congratulations.
Thank you so much.
Sounds like it's been a great run and you've helped a lot of organizations.
I've really enjoyed it. I'm looking forward to our conversation today.
That's awesome. And something that people might not know about you, and I recently learned about you, is that you're an arborist. I don't know if that's the right term, but in particular, you have fruit trees. And is this like a Utah thing? Because I've never known people like with fruit trees until I got out here.
I don't know if it's a Utah thing specifically, but I love apples. Apples are my favorite kind of tree. I have a peach tree, I have a cherry tree, but I have 7 apple trees. Yeah. On a pretty small piece of property. There's this one particular kind of apple actually called the McCown. And
I used to pick those in New England.
Yeah, exactly. They're kind of revered in the Northeast.
Right.
And I've always wanted a tree, and I always, wherever I land, I find a farmer's market and I try to find the person who sells these apples. And in Chicago, I had a farmer's market stand that I would go to get the McCown.
Okay.
And then I moved to Utah, and I found at the downtown farmer's market here in Salt Lake, I found somebody who sold McCowns and actually became good friends with this person. And I still get supplies every year because my production does not meet my demand. But I decided that once we bought our house in Utah, I missed the boat on planting a tree when we lived in Chicago. I lived there for about 17 years. And so the first thing I did was I put a McCown tree in the front, and I've gradually increased my collection.
So that must be like a nice outlet from data science and analytics and strategy to like do something tangible and get some apples on your tree, pick the apples and give them to people. It's like it's much more tangible. Maybe not. I don't know. Is it like
absolutely
more of
is.
Like a tangible, like physical thing than a lot of the things you do in your like professional life?
Absolutely. And the interesting thing is I have a twin brother, an identical twin brother. Yeah. And my brother is a plant breeder. That's his profession. He develops new kinds of green peppers. So there's maybe some kind of a genetic component about all this.
Okay. Yeah. So it's like in the family as well.
Yeah, exactly.
And like, do you ever think when you're working with apple trees and harvesting and kind of setting them up and figuring out what you're going to do, like a correspondence to data? I think we talked about this a little bit. Maybe you can elaborate on that a bit.
Yeah, there is kind of a parallel. So, when you tell people you're into apples and I have a dream of having an orchard someday, right? And the question is, what kind of apples are you going to grow? And it's a good question, and it's a very valid question, but the real question about what kind of apples you're going to grow, it's not just what you like, but like, what's the purpose of your orchard? Like, are you going to grow commercial varieties and sell them to grocery stores? Because that's one whole group of, they're bred for shipping and shelf life. Or are you going to do something more local, have families come and pick apples in the fall, in which case you might want to focus more on heirloom varieties. And really the business purpose of your orchard, the resources that you have, drive your decision on what type of apple to grow. And right. I kind of see like a parallel in the data world, right? People want to know what your technology stack is. And that's a good question, very valid question. But the real question is, what are you trying to accomplish? What are you trying to accomplish with your data goals? Are you trying to support research? Are you trying to support operations, patient care, all of the above? Are you trying to commercialize? There's a whole bunch of questions there, and a bunch of questions about who your customers are and what kinds of questions they're trying to answer,
right,
that really then drive those decisions about
so
how
that's
to
a
build
good metaphor. But
Yeah.
let me just stop you there for a second. So like you liked the McCown apple, so like there's a limit to the metaphors, right?
Yes, absolutely.
Like you got into it because you had the guy in Chicago, you liked the McCowns, and
Yeah.
you personally wanted that, but then you started thinking about some of this other stuff as you
That's my home
your
orchard
tree production.
Yeah. I have no desires to make money on my current home orchard. That's right.
So you've got like an artisanal orchard. I
Yeah,
imagine that where you're giving them to friends and family.
exactly. And my production is pretty low yet. It takes a while to get good mature trees, but I do pick varieties that are harder to find because they don't have great shelf life, but they do have superior taste. And so that's my goal with the apple orchard, is to just have good apples.
So you've been working with small language models versus large language models. And maybe you can just give me a little bit on what that means. What is a small language model, AI, just to start?
Yeah. Well, I think about what are some of the roadblocks in adopting AI. And I will say, a lot of when the AI first came out, most people were using it through a chat interface. Most people were using these AI models through a chat interface. And I'm talking about not when they first came out, when they got really popular here in 2022, 2023. And the vendors, OpenAI, who really kind of pioneered the chat interface, also had APIs on the back end. So people who were writing programs could call these models and do things programmatically versus just typing it through a chat interface. But there's a lot of privacy concerns with that, obviously, in healthcare. And I will say these big vendors haven't done a ton to really make people feel like their health data is really safe there. So in parallel to this, like, development and commercialization of these massive models, there's also been a lot of work developing smaller versions of these things. Smaller versions, meaning you can not have to call it on a server, but you can put it on your own servers, or you can put it on your own, even your own laptop. And so this method of using these, of course, it solves this privacy concern. You don't have to send data out anymore. You can send data internally to another server on your network, or even running on your laptop. So there's obvious benefits there for healthcare, right? There's been a lot of innovation and a lot of desire to adopt AI, but let's remove that whole privacy concern and use them locally.
Right. And we're not talking about little players here, right? The ones, the companies that are offering or that you're using for these small language models are like Meta, Google, right?
That's right. Meta, Google, Microsoft, and IBM actually has a really nice set of small models.
Right. So in healthcare, let's get into, you started getting into some of the advantages of doing that. So one is privacy, I think you mentioned. So rather than setting up a HIPAA compliant structure with an LLM where you're sending, you can access the data within the health system or within the provider, and you don't have to go beyond it. So it gives you a privacy and confidentiality advantage.
Correct.
Right.
Yeah. And I should say that there are ways to use larger frontier models in a private way, but this is just another way to get started quickly and to try things that maybe use less compute resources as well.
Right. So that's a big advantage. And then tell me about cost a little bit too. Like, what is the cost of, maybe take a use case that you've worked with an organization on? What would that be, using an LLM versus using one of these SLMs?
Yeah, the SLMs reduce the cost significantly because, number one, you're not paying per token. That's the way a lot of those public APIs work, is that you pay per token.
Right.
And everything you run, it kind of linearly kind of increases your bill. With the small language models, you're using them on local resources, and many times like very modest resources. Like the models that I use in the training course are designed to be able to run on a modest to large size laptop, 32 gigs of RAM, for example. And so the costs really are basically all of your internal costs, like your servers, your hardware. You've kind of already paid for that. I don't want to say for free because it does still cost compute time, but it's orders of magnitude less expensive than calling these API services.
Right. Yeah. That's awesome. So that seems like a big advantage. And what about in terms of like kind of query ability, data quality, the types of insights on the data that you can pull out of these things?
Yeah, well, I think that's like one of the bigger reasons why I think this, like getting healthcare organizations to understand small models, because truth be told, there's a number of different kinds of models. You have one type, which is the generative models, where you give it text and it's kind of like this autocomplete on steroids and it generates text for you. That's the kind of models that we interact with when we're dealing with ChatGPT. But there's smaller versions of that can run very efficiently on local hardware. But there's also other kinds of models that make it really easy to do things like compare text and find similar text passages. And this is a problem that we've been trying to solve in healthcare since as long as I've been working on it. And so there's a whole new toolkit available with these different models to solve longstanding problems. Number one, how do I extract data from text? Right. How do I take a clinical note and extract meaningful data for that I can turn into analytics? The other is,
and can a small model do a better job at that?
It's a better job. Better is a loaded question. Can a small model do a good job? Absolutely. Can a small model do the same job with less resources? Absolutely. It takes a little bit more elbow grease, a little bit more specific prompting, because these small models, they have less parameters. And parameters, if you're not familiar, it's kind of a measure of how intelligent the model is. So they're not quite as intelligent, but once you get them tuned to your specific use case, they can do that use case more efficiently and for less resources. So there's those advantages as well.
Is that kind of easier to measure with a small model, or easier for an organization or team to get started with and show to their organization demonstrated ROI with the small models, or is that not much of a difference?
I think it is. I think it is because it removes a lot of the barriers to doing like more expensive experiments with larger models. Right. So it makes I think it makes the organization more agile. They can run these tests and benchmarks. And one of the things that we do in our training is we walk through how to benchmark a number of different models against the same task. So you can see how those different models perform against that task. And I think that the flexibility and the lower barrier to getting started really accelerates that ROI and gives you perhaps a better story for a win in a shorter time frame than
shorter term win. And maybe you could take that shorter term win, less resources required. You get something done. You show the advantage of bringing AI into your operational or clinical processes. And then maybe you can argue for more resources. And that's either more of these models or a larger model or an agentic type of model.
Absolutely.
Does that make sense?
At 100%. And I think agentic is getting all the press right now. And it, for good reason. I mean, it's wild what agents can do. And if people aren't familiar with agentic AI, it's taking some of these really advanced models that can do what is called reasoning. There's some debate about whether it's truly reasoning or not, but it looks like reasoning to me. And these models, you pair them with a set of tools, and then it can start to operate on workflows. It generates its own checklist and it starts to execute all these tasks. And that is like getting all this attention. And I think it's, again, rightly so. But what's going to be powering that agentic world is all of these lower level services. And having a good strategy on building up these lower level services so that by the time your agentic strategy continues, that you have the right underpinnings to power that. I think that's where a lot of this comes in at the strategic level.
Yeah. So it seems like maybe you could characterize it as more of a a grassroots or grounds up approach to developing the models, the projects, the use cases, and then demonstrating that ROI, getting organizational buy-in, and then expanding up from there rather than a top-down, which is, it's not necessarily top-down, but it would seem to steer you more in that direction. If you're going to make a big purchase, commit more resources to a large model with agents, and you've got a bigger organizational change process to implement as well.
Absolutely.
And that could set you up more, it's just riskier. It could set you up more for failure rather than starting a little smaller and then building up from there.
Yeah.
That's how I'm kind of thinking about it.
That's exactly right. And I think there's a lot of work happening in the vendor space. And I think having a lot of individuals who understand how these pieces fit together, even if you're not building everything yourself, it's going to make you a better consumer. I was just on a call yesterday with somebody who's interested in the training, and they made that point, and I thought it was a incredible point that, like, hey, we want to be able to understand what's in the box when we buy something from a vendor, and we'll be able to ask better questions and understand how those pieces fit together.
Yeah, that's great. And so with the organizations you're working with, or any large organization, and there tends to be institutional processes, some bureaucracy, and then the team executing it, and then getting buy-in from other parts of the organization. And maybe talk about that a little bit. Like, how have you found that coming into teams, kind of what they need to do, what kind of training they need, and things like that?
Yeah, I think, when I come in, I often see a dynamic in many, many organizations where AI is treated almost like an elite skill. Mm-hmm. You hire a team of data scientists, and they're like the special ops, right? They come in and they do, and those teams are super valuable to an organization. I want to be very clear on that.
Yeah.
But there's oftentimes, like,
and do those tend to be internal teams or external? Or
those tend to be internal teams for sure. Yeah. Often the brain trust of the organization.
Right.
But there's a gap, because there's a lot of, especially for a data-driven organization, there's a lot of people working with data who can make valuable use of AI, even if they're not developing an agentic system. And this was the case with the first group that I did this training with, was that they really wanted to get their data workers up to speed on these tools and how to quickly adopt them locally, so that they could be, again, building the data infrastructure that's going to be necessary for those agents to take off in the bigger, let's call it more moonshot type efforts. So yeah,
right.
And so the goal is to get those groups up to speed on how to use AI and how to apply it. And I'm going to put a little editorial too on just the life of a data worker right now. It's a little bit scary. You're hearing about your job being replaced, and I personally do not see that happening anytime in the near future. So I think it's a great time for organizations.
I agree with you on that. I think jobs are going to change for the most part. Some jobs will be lost for sure.
Yeah.
And we're seeing a lot in the press about entry-level jobs, kind of some of them being at risk, people coming out of colleges and so forth. And I think that is something to take a look at. And it's real in some areas. But
for sure.
But a lot of areas, it's going to be transforming those jobs into higher-level jobs where the data scientists or analysts or executives are doing different things, interpreting, providing advice, counsel, strategic input, and things like that. Is that how you see it, or close to it?
Absolutely. I just think right now is a really good time to invest in people.
Yeah.
We've heard it all now about agents and robots taking over, and it's a very good time to think about your human resources, because they are still super valuable and will continue to be super valuable.
Yeah, that's great. So what's the difference between like a consumer using AI and the folks you're working with who are on dedicated teams? It's their job to get these projects up and running. Like, what kind of training, capabilities, kind of understanding of the technology is required? And maybe the answer is like, not just consumers, but normal people doing their jobs using AI. They should be getting more training and learning as well. But what is your take on all that? Like, what's the difference, and what do people need to know about using these tools?
Very, very good question. So I think, the consumer use of AI, and I've been asked to help organizations think about how business users can use AI more effectively. And I have a whole bunch of tools that I recommend in that space. But in general, you're sitting at a terminal or, a phone, and you're asking questions and you're getting things back. It's kind of like like a web type experience where you have a single question you want to answer, and you can use these tools to get, a full report or an answer. A data person tends to ask like millions of small questions together. And so you're really building a pipeline and a program to go and use these AI algorithms as part of a broader workflow. So it's very rarely a single shot, like, hey, I'm going to get an answer and I'm going to stick it in a database. There's other data tasks around that to clean and normalize the data. And it's just a very different experience. You're generally doing it in pairing with software. So you're calling these things from, in my training course, it's Python. You're calling them from a programming language, and you're doing, instead of like one or two big questions, you're doing, thousands up to millions of little questions. And how do they all fit together? So does that help? Is that like kind of what you're after?
So these folks are maybe using the tools in a much more structured way, kind of creating maybe a hierarchy of questions or a panel of questions that they want to use the technology for, maybe developing that over time rather than just a prompt and putting in a question, getting an answer.
Yeah, and you have prompts too. Like the prompts are, especially if you're using a generative model. Again, I distinguish because there's a lot of different kinds of AI models that you can use, but there are prompts to say, I'm going to give you a pathology report, and these are the data elements that I want to pull out from the pathology report. But instead of executing that once, you're executing it and then you're executing it thousands of times with different pathology reports, and then interpreting the results that come back.
Right. Yeah, got it. So kind of segueing from there on the pathology, because I think pathology is a good use case in healthcare, since it's something that, sometimes humans make errors that machines don't, or the AI will see patterns that humans don't. Maybe you can talk about some of that and some other use cases that are good fits for AI in a healthcare setting.
Yeah, perfect. Okay, so pathology is very near and dear to my heart. I worked on a pathology project 20 years ago at Northwestern, and it was a breast cancer researcher, and she wanted to look at patients who had a specific tumor marker indicated in the pathology. And so I was using a technique called regular expressions, which has been around forever, and it's basically pattern matching in a programmatic way. So I said, okay, well, this is the pattern. It says HER2, and then there's a few characters afterwards, and that's what I want to capture. I want to capture that.
Right.
And it took me, maybe getting through 30 or 40 reports to understand that the way that they're structured is not structured enough to predict what it's going to look like. So you're left with something that works like 80% of the time, and it doesn't work the rest of the time. It's the regular expression approach is very brittle. Yeah. So that's been around forever, and pathology data collection has come a long way, but it's still an issue. There's still, like, for most organizations, pathology, by the time it gets to the analytics team, it sits in a text report, and you have to pull out specific tumor markers in order to find what is the patient's, tumor profile look like. So same problem, but now we have these great generative models where you can actually prompt it and say, I'm looking for these tumor markers, and by the way, this is what they look like when I see them, and you actually get decent results. And this is a use case that we go through in the training. So that's like one use case, is like extracting information from pathology reports, and it kind of you can kind of generalize it to extracting medications from a clinical note. There's like a lot of different things you can do extracting things from text. And that's like that kind of the obvious use case, but there's some like less obvious use cases that are using.
Yeah. What are some of those other use cases? Maybe one or two others.
Yeah. So there's a model type called an encoder model. They actually came out, they kind of just preceded the whole ChatGPT thing. And they were super, super interesting models that take a bunch of text and they abstract the meaning into a matrix of numbers. So you go from, not from text to like, text like we do in the GPT models, but we're going from text to numbers, and which doesn't make any sense at first. But the cool thing about those numbers is you can do similarity comparisons. So you can, like, age-old problems in healthcare like deduplication. I get a record and it's not exactly the same as something else I have in the database, but it's close enough to where I want to merge those two records. Now with this mathematical representation of the text, you can use this kind of model to do this similarity searching. And it's very effective for things like deduplication and mastering of data, which have been, big challenges. So that's another technique that's out there. It's kind of been left behind by the agentic hype, but it's super valuable. Super valuable.
Right. Okay, that's terrific. And I think we touched on this a little bit earlier, but what are some of the limitations of the small models? I think, we talked about prompting, we talked about, the level of intelligence, but maybe just kind of talk a little bit more about that.
Yeah. So the models are, in order to run them on commodity hardware, the first thing you have to do is like remove a lot of the precision of what you have in these larger models running on specialized hardware. So the first thing you do is you take all of the numbers, the parameters that make those big models, and you shrink the space that they fit into so that you can have a smaller model. It's a process called quantization. And that it doesn't remove as much of the fidelity as you would think, but it does remove fidelity. And then the other thing is reducing the parameter count. So you're also reducing the number of parameters and you're reducing the precision of those parameters. So they are not as smart. It's harder to get them to reason, but they are definitely smart enough when you give it the right prompting. And sometimes you have to give it extra prompting to get results. So you lose the fidelity just in the process of creating these models that can run on regular hardware.
Okay, that's helpful to know. So what is a mistake that you see organizations making in their AI investments, and what are some of the better decisions or redirects that you've been part of?
Yeah. I think I see a parallel between what's happening in AI with what's happened in analytics. And I'm going to not answer the question first. I'm going to just talk about a little bit about the healthcare analytics adoption framework and what that looks like. And I'll just talk about how I see the parallels, but it's very similar. So the healthcare analytics adoption model, it was developed by Dale Sanders, who's a mentor of mine. And it kind of walks through this progressive model that organizations should make it through before they get up to the highest levels of analytic use case.
Right.
So at the top, you have, like, back in the day, it was all about predictive analytics, and everybody was putting a lot of time and effort into developing predictive analytics. But those in the know really understood that you had to kind of build up the lower levels of the adoption model, things like data ingest and data harmonization and data standardization.
Yeah.
And
you
it
can't
took a
get
while
to the higher levels without having like good quality data that's clean, that you can get insights out of and things like that.
Exactly. And it took a while for organizations to really understand that they needed to invest in that way. Right. And I still see a lot of organizations under investing in the lower levels.
Right.
But I see a parallel with AI adoption is everybody wants to build their agent. Everybody wants to build this agentic layer, and it's really cool. And you can do some very interesting things very quickly. But sooner or later, your agent is going to really rely on your data infrastructure to provide a good context.
Right.
And by underinvesting in that layer, and there's a whole new set of toolkit. There's a whole new toolkit around retrieval, and especially with text data. Invest there too. Now, I'm not going to say don't invest in your agentic layer, but invest there too, because that layer is what's going to be powering the agentic layer in the very, very near future.
Sure. It's easy to overlook that. And not think about it.
And I see a lot of organizations really focus. Of course, you want to focus on the most exciting thing, but being strategic about, that's a tough message to communicate sometimes, because that lower level is quite technical, and a lot of leaders do not really want to get into the technical. And I really encourage data leaders to go there because I do believe it's the best approach.
How can they do that in an organization where they're hearing from an executive or a committee that they need to show a result and they need to have the most powerful tool in place? How do they explain that kind of need for the technical groundwork?
Yeah, that's getting into what I do in the data strategy space.
Yeah.
So before I did this AI training, I've done now numerous strategies with different organizations. And that is the exact purpose of the strategy, is to kind of fill in that middle. There's a huge gap oftentimes between an organization's appetite, what they want to do at the top layer, and what I call the data reality. And the data strategy really sits in between, and it's a communication tool for executives to help executives understand what's needed, and also for executives to communicate even higher level what's needed, what kind of investments are needed to move things forward. But that's
it seems like healthcare, like a lot of healthcare organizations have a healthy skepticism of AI tools because they've been sold a bill of goods over the years of, you know, all these tech tools that are going to dramatically reduce cost or improve care or measurable results of one kind or another. Has that been your experience? I've kind of experienced that with healthcare people.
Absolutely. I see that all the time. A lot of skepticism about any kind of technology. And I think part of it is rooted in that technology did sell. Like technology and vendors did sell like this is going to make your life a lot better. And when in reality, the root of the problem are these gnarly data issues that just take elbow grease and determination and a pragmatic approach to fixing. Until you do that, it's hard to see results.
Yeah. Yeah. Well, I think one of the benefits of AI may be also just solving that kind of base level problem, making it easier to access the data, clean the data, you know, doing these kind of tasks that people don't really want to do or think about, but it may make them more efficient. Are you saying that?
100%. That's exactly what the training is designed to do. And it's actually not that people don't want to do the tasks. It's just been that the tooling for the tasks has been complicated. Like I could draw you a diagram of what our NLP infrastructure looked like in 2008. You had to have all these different components. Now it's self-contained. It's a lot easier to adopt, but there's a lag now because now you have to learn this additional toolkit. But it is 100% applicable to fixing some of these longstanding data issues. And that's exactly what the AI training is supposed to address.
Yeah. And then, so this is the kind of thing that excites us as like data scientists and, you know, healthcare people, but isn't maybe the headline grabbing or sexiest thing in the world. But, you know, when you get to the point where you really need that data to lean on it, to get those insights out of it, to feed an operational process, which really works and generates an ROI, you can get to that point, and if you haven't done that first part, it doesn't work.
That's exactly right.
Yeah. Okay, I'm going to ask you just kind of a off-topic question. Well, not off-topic, but getting you to speculate a little bit. Will AI destroy jobs in healthcare, or will it create jobs?
I think in the near to midterm, it's going to be more effective at creating jobs.
Yeah.
I haven't seen even the best workflows. I have not the best agentic workflows. I've seen them automate things, but I still think there's a need for a conductor. I wouldn't trust an AI system running autonomously at this point.
Yeah.
I think,
you need the human in the loop.
A human in the loop, exactly. And I think, you know, just kind of segue into like what a good place to start. Anytime you have a human in the loop process is a great place to apply AI because you have like a measurement built into the system. So yeah, I think for the near to midterm, I don't see it erasing jobs. I see people maybe holding back on hiring because they're unsure, but I think pretty soon we're going to start to see, okay, well, we actually need somebody to go in there and fix this and somebody to go. And you know, some of the problems in healthcare data, I call it like cultural anthropology. You really have to understand who to talk to understand the history of why this is the way it is. It's not sitting in a document anywhere. There's no context that you can feed an AI model to understand some of the issues that exist inside the data.
So like next 5 to 10 years, so we've had this intractable problem in healthcare. We've thrown everything at the wall and built tons of different solutions, but still costs keep going up and quality measures don't budge a lot. Do you think, this is kind of zooming out from individual organizations, ROI, demonstrably being able to point to AI and the systems and processes and people put in place to deal with it to affect that change? Will we see movement, positive movement on cost and care delivery?
Cost is tough. I would definitely say I like where the industry has started. I really like this notion of the ambient scribes and really focusing in on the physician burnout. That's like not an area that I necessarily get super involved in. That's more like generally being implemented on the EMR. But I think that's a very good place to start. And I think there's some, I'm not sure exactly how you would measure the ROI, but definite like problem in healthcare right now is documentation burnout. Right. I love where that's going. I would definitely say, at least for the cost of generating quality metrics, there's going to be an ROI. Healthcare's hidden secret is that when you can't get good data, you throw bodies at the problem. Mm-hmm. So think about like people who are chasing down all these quality measures. Think about cancer registries that are like spending like a lot of time just manually looking at records and pulling up. I think those groups are going to see a lot of ROI, which eventually, filters into the system. As far as like,
you would hope that will improve labor productivity over time, and that'll make things more efficient.
And as far as the cost of care goes, I think there's probably good cases to be made that AI will eventually, and I don't think this is a near-term thing because I think it's slower to adopt in healthcare, and you also have to be very careful about patient-facing and clinical decisions. But clinical decision support gets better. We started getting, more precise about specific treatments. I think AI will definitely aid in that, and that is one of those big cost levers as well. But I think that's honestly a bit further out, just because I know healthcare and I've been involved, and I see how long it takes things like that to happen.
Healthcare takes time.
It does.
But things do change over time. We have electronic health records. When I started my career, everything was on paper. So let's talk about a starting point to get things going. That was kind of important, right?
Exactly.
Get the data into a structured format, even unstructured.
Yeah.
Somewhere you can use a machine to do something with it.
Well, the fun thing now, Dan, is we can just scan all those old records in.
Yeah, that's great. Well, I really look forward to see how everything develops in this area for your practice and the organizations you're working with. And it's really going to be an interesting ride over the next few years. And I think we're going to see some big developments.
I think so too. I'm like super excited. I will just say I have never been more excited to be working in technology. And I am super grateful for you for bringing me on today. And
thank you for coming.
For continued friendship and collaboration.
And that concludes our episode of Free Flow. Thank you for joining us today. For more information, please visit our website at orensteinlegal.com and navigate to the podcast page. Remember to subscribe or follow Free Flow on Spotify, Apple Podcasts, and YouTube so you never miss an episode or update. This podcast is for informational purposes only, is not legal advice, and does not create an attorney-client relationship. Thank you for listening.